In this video, we're going to try transforming this worn-out motorcycle into a futuristic space bike, rain-resistant, and unlike anything you've ever seen before. The idea is to convert this bike into one with an enclosed or covered cockpit, as if you were riding a motorcycle straight out of the future. First, we'll bring the bike in without the wheels, leaving only the engine. We'll start by removing the chain and the exhaust system entirely. This particular bike is a Yamaha YZF 1000 with a power output of 152 horsepower, a true Japanese rocket. After that, I'll drain the oil from the engine and then begin installing the wheels since some parts were broken. We'll also fit the exhaust and chain before attempting a quick startup and test run. Next, we'll adjust the bike's height slightly lower because the enclosed cockpit we're building is going to be shorter and not too tall. We'll start by removing the fiber around the rear light, followed by the seat itself. Here, you can see that the cockpit frame will fit properly. We'll then take the necessary measurements to build a new seat base, since the seat height has been altered. Naturally, everything here has to be custom made. Now, looking at the frame that holds the bike, the last issue is that the leather seat cover is a bit too long and doesn't fit the new seat structure. So, we'll reshape it to match perfectly. We'll remove the plastic holding the leather and the seat's foam, then cut off the excess with scissors before stapling the leather back tightly onto the seat. At this point, we've got a brand new seat that matches the bike's size and height perfectly. After installing it, we'll move on to fitting the body's fiberglass panels and creating new wiring connections for the battery, since we had to cut some wires, particularly the indicator wires. Thankfully, the new wiring worked fine. However, there's a metallic section between the seat and the bike's body that looks quite unpleasant. To fix that, we'll use a decorative patterned plastic sheet, cut it to size, and install it to cover that part. Once fitted, it looked very neat and stylish. There were, however, some issues with the bike's front headlights. So, we'll create new wiring connections to get everything fixed. Even though some parts of the headlight are broken, they won't cause any problems. After connecting the wires and installing the headlight, it actually started working perfectly. Next, I'll bring in the fiberglass section for the bike's front end and mount it, along with the other front fiberglass parts. Now the bike is ready to run again, and it already looks amazing. Now, let's see how we're going to build this cockpit. We'll take some metal strips cut lengthwise, move them into the garage, and begin taking measurements and cutting them to size. We'll form a cube-like structure by assembling and welding the pieces together. For the welding, we'll first get a cleaning solution for the metal, then coat the table in a yellow-orange paint. After painting, the result looks fantastic. To fabricate the cockpit, we'll need a heating chamber. For that, we'll repurpose this old car and turn it into a heating chamber. We'll start by cutting it from the sides and removing the top section. Once that's done, we'll flip it onto its side, roll it over to our work table, and install wheels to make it movable. After that, we'll add some boards to the top and bottom to create a proper table-like surface. At this point, it's ready, and we can begin preparing the heating chamber. We'll add extra wheels to improve mobility and give it a thorough wash to clean it up. Then we'll line it with foil or heat-retaining sheets, which are essential for any proper heating chamber. After that, we'll bring in some malleable metal. This type is very easy to shape however we want. We'll form it according to the bike's exact measurements in all directions. Then we'll make the two pieces that will support the cockpit's roof and proceed to build all the frame sections for the new cockpit. After mounting it on the bike, we'll see that it fits perfectly. Then we'll remove the frame from the bike, place it on our work table, and begin wrapping iron wire around the cockpit structure. Now we'll bring in the foam material to cover the entire frame, and at the same time, the order from HPM Company arrived, supplying us with the machines and tools we'll need. The foam covers the whole frame, and we'll leave it to dry for a while. After that, we'll take a saw or any sharp tool to start cutting the foam. Here, we're also making a large sanding tool to smooth the foam down. After a long period of sanding, this is how it looks. It takes on an oval shape. Since the foam still has several holes, we'll refill them with more foam because the goal is to have one solid flat surface. We trimmed off the excess so it would be accurate, then went back to sanding. Next, we'll apply putty to smooth over the entire foam-based frame. Meanwhile, the remaining equipment arrived and we set up another work table to allow us to weld and melt the metal fabric more comfortably. Returning to the frame, we sanded it again and added another layer of putty. The objective is for it to be completely flat and smooth, and surprisingly, that's exactly what we achieved. We'll now leave it to dry for 24 hours. After 24 hours, we return to sanding again. The 2 points on the bike where the cockpit will be mounted are not strong enough, so we'll reinforce them using small metal pieces attached to the frame. We'll weld L-shaped metal brackets for extra strength, then reinforce the frame and fiberglass so that they become extremely durable. And indeed, that's exactly what happens. There's also a section of the fiberglass sheet that we'll cut out, which doesn't take much time. Then we go back once again to sanding the frame. It's a lot of work, but the final result will be astonishing. Sanding the frame alone took 4 full days, but we finally finished it. Now, we'll bring in pieces made of tough foam to place inside certain sections of the frame. Then, we'll go back to the work table where we attach hollow pipes with connectors to build our heating chamber. We'll gather a large number of heaters, dismantle them from their casings, and keep only the heating elements. Afterward, we'll take these heating elements and start fixing them inside the heating chamber one by one, securing each in the floor of the chamber. At this stage, about 10 units have been installed in the base. Here, we'll start working on the side of the car. After installing the wheels, it became very difficult to flip it over, so I needed some help. Once we managed to turn it, the wires on the floor became visible, allowing us to connect them into a single circuit. We also installed a main switch to power all the heaters at once. To ensure there wouldn't be any problems, we gave each heater its own switch, with every 2 heaters connected to one plug, making it 5 plugs in total for all the heaters. Now it was time for testing, and indeed, this great invention worked perfectly. Soon after, the order for the covering material that would be used for the cockpit arrived. But first, we went back to working on the table, preparing it to hold the cockpit and its frame. We covered the frame with a piece of fabric, and then we had to heat the plastic glass sheets so they would take the exact shape of the frame. Heating them thoroughly was essential. We brought in the sheets, lifted them up, and secured them onto the table. Once the covering was heated, we had to place it over the frame immediately. We only had one attempt. If the cover didn't fit correctly, we'd lose around $400 and risk damaging the cockpit as well. So I began by removing the softened cover and quickly placing it over the frame before it cooled. Unfortunately, the cover wasn't heated enough and failed to take the cockpit shape. Not only did we lose the cover, but the frame was also slightly damaged due to the pressure. So now repairs were necessary. I went back to applying putty and sanding again. The new plan was to install 5 additional heaters in the heating chamber to improve performance and prevent the same problem from happening again. This brought the total number of heaters up to 15. The replacement cover arrived along with the extra heaters. We dismantled the heaters from their casings and expanded the chamber to accommodate them, arranging them in 3 rows with 5 heaters in each row. Once installed, all of them worked perfectly. We then flipped the car back onto its base so the floor was facing upward, making it easier to work on. Finally, we brought in metal parts and mounted them directly onto the frame. The purpose of this piece was to allow the chamber to be suspended from the ceiling, and the metal would be firmly fixed into the roof. After that, we carried out a simple test of its durability. The first cover had been made from wood, which was one of the reasons it failed. This time, we built it from metal. The advantage of this table is that any kind of metal welding can be done on it easily, and it's strong and durable. We made a square frame from metal pieces to serve as the support for the cover. Then we brought the cover, mounted it onto the frame, secured it inside the heating chamber, and began heating it. Once it was properly heated, we removed it and placed it over the frame, and thankfully it fit perfectly. After the cover hardened on the frame, we trimmed it and tested it on the bike. Unfortunately, the motorcycle tipped over and the frame turned out to be slightly too tall, so we had to cut it into 2 halves and adjust the size. Then we brought a new cover, heated it, and placed it over the two halves of the frame, and this solution worked successfully. At this point, we started cutting and adjusting metal parts so they would fit the bike precisely. To build the frame around the transparent section, the metal had to align symmetrically with the cockpit. Using L-shaped tools, we were able to bend the metal into the exact shape we needed. Once we had installed them, the cockpit's form was complete. Next, we painted the areas of the bike where the cockpit would be mounted, coating them in black, since the cockpit itself was designed to be black. The components we added worked like springs, allowing the cockpit to be raised and lowered. Then we proceeded to install the cockpit on the motorcycle and took measurements for the new mirrors. This is how they looked after installation. The mirrors also had built-in signal lights, so we connected the wiring and confirmed they worked properly. Inside the bike, there were empty spaces that needed to be sealed, since the purpose of this enclosed cockpit is to protect you from rain and the weather. So we made custom metal pieces, mounted them to the cover, and adjusted their sizes to perfectly close the gaps. The cover itself was a type of fiberglass, but transparent, with the advantage that it could be shaped into any form while still being strong. Here's a fact you might not know. The Chevrolet Corvette, up to its 7th generation, had its entire outer body made from fiberglass precisely because of its light weight. After installing the new pieces, we painted the seat base black to match the overall look. We also added a front spring system for better movement and secure mounting, then attached the company's logo. At this point, it started raining, which was the perfect weather to test our invention. And indeed, the invention worked. The rain was pouring outside, but not a single drop made it inside. This design not only protects the rider from rain, but also shields the engine from water, preventing rust and preserving it completely. The modified bike looks like it came straight from the future, or like an actual spacecraft. So, tell me what you think of the video. Let me know what other challenges you'd like to see next, and don't forget to subscribe to the channel. Thank you.